Okay, Walkcast. Today we're looking at 10.4 assignment tutorial, solving exponential equations. Question 1 of 16. Solve the equation 5e to the 0.1x equals 90 graphically. Round your answer to one decimal place. Okay, so to do this, we're going to use Desmos. All right, so let's go to desmos.com, graphing calculator. All right, we're going to graph y equals 5e to the 0.1x, press enter, graph y equals 90, and then we're going to come over here and we're going to zoom out, maybe put it down a little bit until we can see the point at which they intersect. And they said to one decimal place, so the point of intersection is here, and all you need is the x value, so your solution is 28.9. Okay, so your solution is x equals 28.9. All right, let's take a look at question number 2. Okay, solve the equation 130e to the 2x equals 85e to the 4x graphically. Round your answer to one decimal place. All right, so again, we're going to come to Desmos. Okay, let's exit out those. And then we're going to graph y equals 130e to the 2x. And then y equals 85e to the 4x. Press enter. And then we're going to come over here. We're going to zoom out. Actually, you might need to zoom in. Yep, looks like we need to zoom in. And I'm going to click on the lines. So in case we did have to zoom out, because when you click on the lines, you're looking for when they intersect. And it looks like it's that point right there. But you want to zoom in and make sure. Okay. So that's actually not the point because that's the y-intercept. You want to find out when they intersect. So in this case, we might need to zoom out quite a bit. Again, that's when you see the 0, that's the y-intercept. But here, that point, you want to zoom in on. Is where they intersect. Okay, so we want the x value to one decimal place, so the answer would be 0.2. Okay, so your solution is x equals 0.2. All right, let's look at the next question. Okay, question 3 of 16. Solve the equation 488e to the 0.02x equals 4 graphically. Round your edges to one decimal place. Okay, so again, we're going to go to Desmos. Let's exit out this and this, and we're going to graph y equals 488e to the 0.02x. Press enter. Before I go to the next, I'm going to press the home key. So we're back to the standard graph window, and y equals 4. Okay, so then we're going to zoom out. All right, make sure we have. All right, so we zoomed in. We're gonna have to, it looks like we're gonna have to zoom out until we see the graph. There, we start to see the graph, and then we click on there, and there's our point of intersection. Okay. So again, we want the x value to one decimal place, so x equals negative 240.9. 2. Okay, so your solution is x equals negative 240.2. All right, go ahead and finish up question 3. All right, question 416. Solve the equation 15e to the 5x equal to 5e to the negative 3x graphically. Round your answer to one decimal place. Okay, so again, we're going to go to Desmos. X out here, press the home key before we start. And then we're going to graph y equals 15e to the 5x and y equals 15e to the negative 3x. Okay, and then looks like we're going to zoom out a little bit. It looks like we're pretty close to the intersection right there. And I'm going to click right here. Now you want to be careful. You want to zoom in. I'm going to zoom in quite a bit. In that case, it looks like the point of intersection is right there at 0, 15. So the x value is 0. But we can zoom in really close. And yep, it looks like 0, 15. So the x value is 0. Okay. Now let's look at the next question. All right, question 5 of 16. Solve the equation 410e to the 0.4x equals 2,665 graphically. Round your answer to one decimal place. All right, so again, we're going to come to Desmos. All right, X out here, press the home key, and graph y equals 410e to the 0.4x and y equals 2,665. And it looks like we're going to need to zoom out. That's a large number, so we're going to need to go all the way up to 2,000. So that's going to take us some time, but we'll get to there. So now we know that that right there is where they intersect. So our solution is x equals 4.68. Okay, so x equals 4.68 is our solution. All right. Question 6 of 16. Solve the equation 485e to the x divided by 3 equals 210 raised to the 2x divided by 3 graphically. Round your answer to one decimal place. So again, we're going to come to Desmos. So X out here, press the home key. And then we're going to graph y equals 485 e to the x divided by 3. Center y equals 210 e to the 2x divided by 3. Okay, and we're going to zoom out. And it looks like our intersection is happening somewhere there, so let's click on the lines. All right. Now, that 0 more than likely is your y-intercept. Here looks like where the points intersect, so that's going to be 2.5. So x equals 2.5. And you can zoom in here, and you can see that at that point they don't intersect. So we know the x equals 2.5 is our solution. Okay. All right, let's take a look at the next question. All right, question 7 of 16. Okay. Use common logarithms to solve 8 to the 3x minus 9 minus 13 equals negative 10. Give the exact solution and an approximate solution to the 3 decimal places. Okay. So first off, we need to add 13 to both sides. So then you have 8 to the 3x minus 9 equals, that becomes 0. Negative 10 and 13 is 3. Okay. Now we need to take log base 8 of both sides. Okay. And now use the power rule, so this comes to the front. So then that's 3x minus 9 times log base 8 of 8 equals log base 8 of 3. Now, this is 1, so that becomes 3x minus 9 times 1 equals log base 8 of 3. Well, this times 1 is just 3x minus 9 equals log base 8 of 3. Okay, let's add 9 to both sides. So we have 3x equals log base 8 of 3 plus 9. Divide both sides by 3. That divides and becomes 1. So x equals, the exact solution is log of base 8 of 3 plus 9 divided by 3. But we know that approximately is, and we're going to plug that into our calculator. Okay. All right. So on new document, add calculator. So press Control divide, Control log base 8 of 3 plus 9 divided by 3, which is 3 point, they want it to 3 decimal places, so 3.176. Okay, go and finish up question 7. All right, question 8 of 16. Use a natural logarithm to solve 7e to the 3x equals 28. Give the exact solution and approximate solution to 3 decimal places. All right, so first step is we're going to divide both sides by 7. That divided becomes 1. We get e to the 3x equals 28 divided by 7 is 4. Now we need to take the natural log of both sides. Okay, this goes to the front, so then that's 3x times natural log of e equals natural log of 4. That becomes 1, so that's 3x times 1 equals natural log of 4, which is 3x equals natural log of 4. Divide both sides by 3. So x equals natural log of 4 divided by 3. That's your exact solution. Now let's plug that into calculator to get the approximate solution. Okay, so we're going to delete that. Control natural log of 4 divided by 3. You can do it that way, or you could have done control divide and then natural log of 4 divided by 3. Either way, we're saying that's 0.462. All right, go ahead and finish up question 8. All right, let's take a look at question number 9. Use common logarithms to solve 6 to the 5x plus 3 equals 9. Give the exact solution and the approximate solution to 3 decimal places. All right, so the exponent is isolated, so now we just need to take log base 6 of both sides. Okay, this goes to the front, so then that's 5x plus 3 times log base 6 of 6 equals log base 6 of 9. This becomes 1, so then that's 5x plus 3 times 1 equals log base 6 of 9. So then we have 5x plus 3 equals log base 6 of 9. So we subtract 3 from both sides. That's 0, so then you're left with 5x equals log base 6 of 9 minus 3. Divide both sides by 5. X equals log base 6 of 9 minus 3 divided by 5. Okay, so that's your exact solution. And let's put that in the calculator to get the approximate. So let me delete this. Control divide, control log base 6 of 9 minus 3 divided by 5. So our answer is negative 0.355. All right, go ahead and finish up question 9. All right, question 10 of 16. Use a natural logarithm to solve e to the 2x minus 5 divided by 3 equals 260. Give the exact solution and the approximate solution to 3 decimal places. All right, so first we're going to take natural log of both sides. Okay, this goes to the front, so that's 2x minus 5 divided by 3 times natural log of e equals natural log of 260. This becomes 1, so then that's 2x minus 5 divided by 3 times 1 equals natural log of 260, which just leaves 2x minus 5 divided by 3 equals natural log of 260 divided by 1. So then we cross multiply. So 2x minus 5 times 1 is 2x minus 5 equals 3 times natural log of 260. Okay, we add 5 to both sides. That's 0. You get 2x equals 3 natural log of 260 plus 5. Divide both sides by 2. That becomes 1. X equals 3 natural log of 260 plus 5 divided by 2. So that's your exact answer. Let's put this in the calculator to get our approximate answer. All right, let me delete this. Control divide 3 control natural log of 260 plus 5 divided by 2. So that's 10.841. All right. Go ahead and finish up question 10. All right. Question 11 and 16. Use common logarithms to solve 10 to the x to the second power plus 82 equals 100. Give the exact solution and approximate solution to 3 decimal places. So first off, when you have an exponent to exponent, you multiply. So that's 10 to the 2x plus 82 equals 100. Let's subtract 82 from both sides. That's 0. You get 10 to the 2x equals 100 minus 82 is 18. So now you do log base 10 to both sides. Okay, so this goes to the front, so then that's 2x times log base 10 of 10 equals log base 10 of 18. Okay, this becomes 1, so you have 2x times 1 equals log base 10 of 18. So then you get 2x equals log base 10 of 18. Divide both sides by 2. X equals log base 10 of 18 divided by 2. Now that's your exact answer. Let's put that in the calculator to find our approximate answer. So delete this. Control divide. Control log base 10 of 18 divided by 2 is 0.628. All right. Go ahead and finish up question 11. All right. Question 12 of 16. Use common logarithms to solve 3 to the x to the divided by 4 equals 48. Give the exact solution and the approximate solution to 3 decimal places. All right. The exponent is isolated, so we're going to do log base 3 of both sides. Okay. This now goes to the front, so x divided by 4 times log base 3 of 3 equals log base 3 of 48. That becomes 1, so then you have x divided by 4 times 1 equals log base 3 of 48. So now we have x divided by 4 equals log base 3 of 48 divided by 1. Let's cross multiply. X times 1 is x. And then we have 4 times log base 3 of 48. Now that's your exact answer. Let's plug this into the calculator to find the approximate. So 4 times control log base 3 of 48. So that's 14.095. All right, go and finish up question 12. All right. Question 13 of 16. The price P of a gallon of gas after T years is given by the equation P equals P naught, parentheses 1 plus R to the T, where P naught is the initial price of gas and R is the rate of inflation. If the price of a gallon of gas is currently 3.55, how long will it take for the price to rise to 4.35? If the rate of inflation is 10.5%, round your answer to 1 decimal place. Okay, step 1, write the equation 4.35 equals 3.55, parentheses 1 plus 0.105 to the T power. Step 2, solve the equation 4.35 equals 3.55, parentheses 1 plus 0.105 to the T for T. All right, so the first thing we're going to do is we're going to divide 3.55 by both sides. Now, this divides and becomes 1. So let's see what control divide, 4.35 divided by 3.55. All right, now we're going to leave that as the fraction because we don't want to write this entire decimal. We don't know if that decimal stops at the 5, okay? So we're going to leave this alone, okay? So then we have 4.35 divided by 3.55 equals, let's go ahead and put this in our, let's go ahead and add this. So 1 plus 0.105. So 1 plus 0.105 is 1.105 to the T power, okay? All right, now we need to take the log base of 1.105 to both sides. So that's log of 1.105 to both sides. Okay. Now, this will come to the front, and this actually becomes 1. So we can actually write this as log of 1.105 of 4.35 divided by 3.55. And we can go from here to equals t. Okay, so now let's plug that into our calculator. Okay, so control log of 1.105 of control divide 4.35 divided by 3.55. And that's 2.035, and they want to one decimal place, so we'll say that equals 2. So t equals 2. So it will take 2 years for the price of gas to rise to $4.35. All right, go ahead and finish up question 13. All right, question 14 of 16. Okay, the amount A in a bank account after t years is given by the equation A equals A naught, parentheses 1 plus R divided by 6 to the 6t, where A naught is the initial amount and R is the interest rate. Suppose there's $440 in the account. If the interest rate is 6%, after how many years will the amount triple? Express your answer to the nearest tenth of a year. Okay, so step 1, you're going to write the equation 1,320 equals 440, parentheses 1 plus 0.06 divided by 6 raised to the 6t. Solve the equation 1,320 equals 440, parentheses 1 plus 0.06 divided by 6 raised to 6t for t. Okay, so the first thing we're going to do is divide 440 by both sides. Okay, this divides and becomes 1. So we have 1,320 divided by 440 equals 3. Okay, so then 3 equals, let's go ahead and get this as one number. So we're going to do 1 plus 0.06 divided by 6 is 1.01 raised to the 6t. All right, so now we need to take the log of 1.01 both sides. Okay, we know this is going to 1, so we just left with 6t. So we have log of 1.01 to 3 equals 6t. Divide both sides by 6. This divided becomes 1. We have t equals log base 1.01 of 3 divided by 6. And let's see what that approximately is. Okay, so control divide, control log of 1.01 of 3 divided by 6. So it's 18.4. Okay, so it says to the nearest tenth of a year. So that's 18.4. So it will take about 18.4 years for the amount to triple. All right, go ahead and finish up question 14. All right, question 15 of 16. You can choose a prize of either $25,000 car or 1 penny on the first day, double that 2 cents on the second day, and so on for a month. On what day would you receive at least the value of the car? Step 1. 25,000 is 2,500,000 cents. On day 1, you would receive 1 cent or 2 to the 0 cents. On day 2, you would receive 2 cents or 2 to the 1 cents, and so on. So on day n, you would receive 2 to the n minus 1 cents. Step 2, solve the equation 2 to the n minus 1 equals 2,500,000 cents. So we have 2 to the n minus 1 equals 2,500,000 cents. We need to start by taking log base 2 of both sides. Okay, so the n minus 1 comes to the front, so that's n minus 1 times log base 2 of 2 equals log base 2 of 2,500,000. Well, that becomes 1, so that's n minus 1 times 1 equals log base 2 of 22,500,000 cents. Okay, so then that's just n minus 1 equals log base 2 of 2,500,000 cents. Add 1 to both sides. So n equals log base 2 of 2,500,000 cents plus 1. All right, so let's plug that into our calculator. So control log base 2 of 2,500,000 plus 1. So that comes out to 22.25. Now, we need to round up to 23. So you would receive at least the value of the car on the 23rd day. All right, go ahead and finish up question 15. All right, question 16 of 16. The number of farms in one U.S. state in thousands can be modeled by n of t equals 125 times 0.963 to the t, where t is the number of years since 1980 according to the model. When will the number of farms in the state be about 30,000? Step 1. Write the equation 30 equals 125 times 0.963 to the t. Step 2. Solve the equation 30 equals 125 times 0.963 to the t for t. So the first thing we do is divide both sides by 125. Okay, so let's put that in our calculator. So control divide 30 divided by 125. And let's leave that as 6 divided by 25. So that's 6 divided by 25 equals, that divide becomes 1, 0.963 to the, and we actually don't need parentheses for that anymore, to the t. So we need to take the log of that of both sides. So log base 0.963 of 6 divided by 25 equals log base 0.963 of 0.963 to the t. Now we know that that's just going to become 1 left with t equals. So t equals log base 0.963 of 6 divided by 25. And let's see what that equals. So control log base 0.963 of control divide 6 divided by 25 is 37.8. Let's round that to 38. So the number of farms will be about 30,000 after 38 years, or in the year 2008. Sorry. All right, go ahead and finish up question number 16 and your assignment, and have a wonderful Wildcat day.